Hello, I'm Antonio Terceiro, and today I'm going to talk to you about building, booting, and testing Linux with one command, locally and at scale. This talk came up in the context of the TuxSuite project, where we are building tools to deliver on-demand APIs for building and testing Linux kernels in parallel and at scale. You can see more details about it on TuxSuite.com. In TuxSuite, building, booting, and testing is supported by tools that you can use locally for your own builds and tests. Those are TuxMake for building and TuxRun for booting and testing. The goals of this presentation is to showcase TuxMake for doing local builds. We'll be going very quickly over that as it was already covered in Last Connect on March 2021. Then you can watch that and see TuxMake in more details. We also are going to showcase TuxRun for running local tests in virtual machines. We are also going to showcase the TuxMake and TuxRun integration, and that's how you can achieve the building, booting, and testing with one command mentioned in the title of this talk. And at the end, I'm also going to showcase building and testing in parallel and at scale using TuxSuite. To install the tools, at this moment, the only solution that you can use to install all of them is pip, which is the Python package manager. So you can install TuxMake, TuxRun, and TuxSuite in one command. And in the future, we'll have Debian and RPM packages for all of them as well. Recapping the TuxMake basics, so TuxMake is run inside the Linux kernel tree, and you can just type TuxMake, it will do a default build. So by default, it will build for the same architecture you're running locally. And it will build a list of default targets. And at the end, it will leave the output in a build directory where you will find the kernel image build, the module starball, and other artifacts from the build. TuxMake supports a lot of options. So for instance, you can build specific targets. So for instance, you can build only the kernel image, or you can also build only k-self-tests. You can also pass make variables, so you can pass, for instance, v=1 to have a variables build, where TuxMake by default will do a silent build, so you can use v=1 to do a more detailed build log. You can also pass specific config options. So by default, TuxMake will build def config for your architecture, but you can also use other configuration parameters, and you can also build starting from a custom configuration file you already have somewhere in your disk. You can choose your target architecture. In this case, TuxMake will look for the cross-compiler inside your host operating system. Otherwise, you can also use the container runtimes. And in this case, TuxMake will download the corresponding container image for Podman or for Docker and do the build inside the container. And one of the features that we are going to be exploring today is the results hook option, where you can pass a custom shell command that's going to be executed inside the TuxBuild artifacts directory after the build is done. And another option is you can record predefined sets of options in files inside .config/TuxMake inside your home directory, and then you can refer to those using the notation @ and name, and that will read the corresponding file inside that directory. This is useful for having those config files with sample options. For instance, you can have one for building for one specific architecture, and then in there you can specify both the -- target arch parameter, but as well as any specific configurations you want to build for that architecture and things like that. Let's now talk about TuxRun, which is a tool to boot and test Linux on VMs. It was extracted from TuxTest, which is the TuxSuite service that does booting and testing. It supports several architectures, so basically we try to support every architecture that TuxMake supports building for. and that support is defined in terms of virtual devices. So we have several QEMU-architecture devices, and you have one for each of the most common architectures. TuxRun is currently alpha software, so it's usable, you can use it, but it's not as polished as, for instance, TuxMake is. So we are going to be working the next months to make it better integrated with the rest of the system and more convenient to use in the lines of TuxMake. And there you have example invocation, so you can use TuxRun. You use the -- device option to specify which device you want to use, and the -- kernel and the -- modules options to specify the kernel image and the modules you want to boot. And then you can specify which tests you want to run with the -- tests option. If you don't specify anything, then TuxRun just does a boot test and doesn't run any specific functional tests. TuxRun has some features that I wanted to mention here. By default, we provide one rootfs for each architecture. If you want to run tests that depend on specific binaries being installed in rootfs, then you can just provide your own rootfs, and TuxRun will use that. Otherwise, TuxRun is going to download one for the architecture you are running and use that. TuxRun has a few curated test suites, so subtests of LTP mostly, where those are ready to use. You just specify their name in the -- test option, and then you run those tests. But you can also pass an arbitrary shell command that's going to be run inside the VM, and that's that way you can support any test that you want without having to wait for support in TuxRun. And of course, if that command needs any specific binaries that we don't provide in the rootfs, then you can then provide your own rootfs, and then that command will run in your rootfs. Let's now talk about how to chain TuxMake and TuxRun to achieve that build, boot, and test in a single command. The first component is TuxMake's results hook option, where you can specify a command to run from the artifacts directory after the build is finished. And the second component is TuxRun's TuxMake option, where you pass a TuxMake artifacts directory, and then TuxRun will go in that directory, figure out which architecture that was built for, find the kernel image and the module starball from that directory, then use those to build QEMU and run the tests. So if you put those two together, you call TuxMake with a results hook option, specifying a TuxRun command, where the -- TuxMake option receives the current directory, and then you use any other options that you want. In this case, we are passing -- tests LTP smoke. This will cause TuxMake to do the build, and after the build is finished, TuxRun will be called from the artifacts directory with those options, and then that will achieve building, booting, and testing with a single command. You can also save some typing by saving those options to a TuxMake configuration file, and then you can just call TuxMake and specify that configuration file name with an @ symbol, and that will have the same results as the first command.
Let's now watch a demo of this integration in practice. Here I'm running TuxMake and passing my LTP smoke configuration file, where I have a results hook calling TuxRun with the right arguments to run the LTP smoke tests. Note that I have TuxMake configured to use Ccache by default, so this demo will take a couple of minutes instead of a couple dozen. Even then, we don't need to watch paint dry, so I'm going to speed it up a bit. At this point, kernel and modules have been built, and a module starball is being created. And now the build has finished, and TuxMake is just starting to run TuxRun in the results hook. TuxRun takes a few seconds to start, since it's spawning a container to run the tests. This output you see here is from Lava Dispatcher, as it's downloading and preparing a root file system. In Special, it's overlaying the file system with the modules tarball. And now we get to the boot part. Here we see that the LTP smoke tests are being run. And now the tests have finished and the VM is being shut down.
So some considerations about TuxRun. Right now we only support virtual machines, so QEMU is the first one and is already supported. We are right now working on ARM FVP models, so that's coming soon. And the test run is actually based on Lava Dispatcher, so maybe with some work we could even support real devices. I'm not promising anything, that's probably a lot of work to support, but that's something that could be thought about if there's interest from people. Of course, it's my duty to let you know that this is never going to support all possible testing needs. There are some testing that can only be done with real hardware, developer poking at the device physically, but then this goes along the way of on allowing people to automate tests against their kernel trees. And some future work for TuxRun is providing proper documentation. So right now there's only pretty much the source code for people to read, and we don't really have much documentation, but we'll work on that soon. And then some polishing work on the user interface. So we want better logging. We want a useful exit status. Right now TuxRun will always exit 0 if it was able to boot the kernel, and we want it to fail if any test fail. We also want to provide Debian and RPM packages and a way of updating the container image that is used to run the tests. Right now it will pick the first container image it finds and it will never update it again. But those are improvements we should be able to do soon. Now let's talk about TuxSuite Plan, which is our feature of TuxSuite where you can automate building and testing at scale on the cloud. So the first point is this requires a TuxSuite account. We do accept people signing up for early access, so you can go to TuxSuite.com and you'll find a link for signing up there. With Plan, you can submit a build and test plan file using the YAML format, and that file specifies what and how to build and how to test those builds. The builds in the cloud are done with TuxMake, the very same TuxMake you can install locally, and the tests are run with the very same TuxRun you can use locally. So this is just automating the orchestration of as many VMs as you want in parallel to run your tests. So for instance, you can call TuxSuite Plan and specify which repository you want to test and which branch you want to test there, or you can also specify a tag, and you pass a plan file where your builds and tests are defined. Let's look at how a plan file is written. So you have some metadata at the beginning, so name and description, and then you specify your jobs. So each job can specify builds and a test to run on those builds. So you probably want to specify one job for each architecture, which is what we are doing here in this example. So the first job is building ARM v7. So those parameters there, toolchain, target arch, and kconfig are the parameters the same parameter you would expect to pass to TuxMake, and those are just passed through to TuxMake. And in the test, in the test part, you specify where to boot those tests, those kernels, and how to test it. So in this case, we are saying that this kernel needs to boot on a QEMU ARMv7 device, and we want to run the LTP smoke test suite. And the rest of the file is similar, just specifying other architectures. And now we are going to see a demo how that works.
Here's a TuxSuite plan demo where I'm submitting a kernel switch build for ARM x86, both 32 and 64-bit. You can see that the builds are in the provisioning stage, so that means TuxSuite is creating virtual machines so that the builds can run, while the tests are in the waiting state because they need the builds to finish first before they are able to start. At some point the builds start to run, and as they finish you see that the corresponding tests start to run as well. At the end you get a summary of each build and the corresponding tests.
And that's it. If you want to talk to us about any of those tools, you can go to the GitLab repositories. So we have one for TuxMake, one for TuxRun, and one for TuxSuite. You can talk to us on the IRC channels, TuxMake and TuxSuite on Libera Chat. And we have a few websites where you can learn more. We have a website with documentation for TuxMake. We have one for TuxRun. As I said, it's mostly empty at the time. By the time you are watching this, might have some documentation, so check it out. And we have 2 documentation sites for TuxSuite. And that's all that I had for today. Thanks for watching, and we can now answer any questions that you might have. Bye.